To conclude his distinguished career, legendary Australian herbalist Dennis Stewart will present his final course, a professional extension in herbal medicine. Commencing on the 23rd of November 2019, this 12-day intensive course will be held over a period of 12 months on the New South Wales Central Coast. This will be your last opportunity to participate in detailed learning with Dennis, covering relevant, effective herbal prescriptions to treat an expansive range of conditions. For more information and to register, please go to lakespa.com.au. This is FxMedicine. I'm Andrew Whitfield-Cook. Joining us on the line today is Dr. Christine Houghton. After practicing nutritional medicine for 3 decades and holding a PhD in nutrigenomics, Christine has built her extensive clinical experience to research, develop and teach other clinicians clinically relevant strategies associated with nutrigenomically active phytochemicals. Sulforaphane, derived from broccoli sprouts, was the focus of her PhD thesis, and she owns a nutraceutical company supplying nutrigenomic bioactives. Her recent research has culminated in the development of the GEM protocol, gut ecology and metabolic modulation, an approach that mimics the processes used by nature to re-establish homeostasis within the gut and with consequent enhancement of cardiometabolic health. In addition to her scientific and lay publications, Christine is the co-author of 2 online courses in nutrigenomics for practicing clinicians and is currently engaged in the development of further online training for clinicians, mastering the GEM protocol. Welcome to FxMedicine. Christine, how are you?
Thank you, Andrew. I'm very well, thank you. How are you?
I'm good, thank you. Now, today we're going to be discussing the antioxidant myth, or where we've gone wrong. So, this was a theory developed in the 1950s?
Probably about then.
But trials with particularly single antioxidants have been, less than lackluster, let's say, and in some instances has increased disease. So what's happened with the antioxidant theory, I guess, first off?
Yes, well, when you look back now with the benefit of hindsight, you can see that our theory was just a little bit too simplistic. We had this idea that all free radicals were bad and all antioxidants were good. And as it turns out, it doesn't really work like that in the cell. And that's to a large extent because we didn't really appreciate the value of the cell's own antioxidant enzyme compounds that it generates, and a number of other enzyme compounds like glutathione within the cell. And it turns out they're quenching literally millions of free radical species per minute and even per second. Whereas when you have a single food molecule, let's say like ascorbate, you have minimal quenching of radical species with that one molecule. So it had to change the way we saw things, and that changed in 1992 when the transcription factor NRF2 was discovered. And It's a bit like a switch within the cell that switches on a whole host of really potent protective compounds.
Let's investigate this. The NRF2 ARE...
antioxidant response element is what it was originally designated.
Yeah. And where does that fit into the big daddy of inflammation, NF-kappa B?
Well, so NRF2 is one switch transcription factor within the cell, and NF-kappa B is a different switch. So NRF2 switches on with hundreds, literally, of protective genes, and NF-kappa B switches off a whole host of inflammatory cytokines. Now, that's not to say that NF-kappa B is the bad guy, because we do need those pro-inflammatory cytokines for a whole lot of processes like infection control. So the cell is very clever because it's got these intricate signalling mechanisms that knows when to put the foot on the accelerator and when to put it on the brake. And it's almost like a racing car driver is got 2 feet working, partly on the accelerator, partly on the brake, and is switching from one to the other. That's the magic of Mother Nature in controlling what goes on within cell modulation.
Do you think, therefore, we need to just get rid of the term antioxidant because it's flawed in even its premise, really?
Look, it is. I don't know how you're ever going to do that because I think
it rolls off the tongue, doesn't it?
Now.
Yeah.
I practically never use it except in one context, and that's when you have a direct radical quenching effect of polyphenols in the gut. So if you have the proverbial red wine with your blackened barbecued steak, you're going to get a direct scavenging effect of those polyphenol molecules in the red wine on the highly carcinogenic reactive species that are in your blackened steak, and you will get a direct quenching effect. That's the only context in which I talk about antioxidants per se.
And that's really, we're talking about the gut lumen content, so it's almost like an ex vivo situation. And this is where the antioxidants shone in an in vitro environment where they could demonstrate in a very controlled cell culture that you had quenching effects of these antioxidant compounds.
Exactly, and that's where the original theories came from.
Yeah.
So it was Dr. Denham Harmon back in the mid-50s, who was a petrochemical chemist, who'd done some of this lab work, and he discovered that antioxidant-type molecules could quench free radicals on the lab bench. Then we translated it some years later, human scientists, into ORAC values. And so, blueberries and acai berries and goji berries and all of these compounds which have a high ORAC value have that because they have the ability to quench or scavenge a number of reactive oxygen species at the same time. But it turns out it's got absolutely no relevance to what's going on within the cell.
And I remember the ORAC value was touted as the be-all and end-all measure of the value of a food mainly. And I've got to say it was mainly involved with multi-level marketing companies, but not only.
I was just going to say exactly that. It was brilliant from a marketing standpoint, but useless from a human intervention point of view, so much so that in 2010, the United States Department of Agriculture, which had the table on its website, not only pulled the table off, but I think to this day still has a statement there to say why it pulled it off. And was most adamant that this is completely useful in terms of clinical interpretation.
Apart from the quote-unquote antioxidant vernacular being incorrect, we still have these compounds which appear to have benefit. Coenzyme Q10 with the Q-Symbio study, with ejection fraction. There's various trials showing benefit with glutathione, lipoic acid in metabolic disease. But
you've just named 3 molecules that the cell makes for itself.
What interests me is in the past, we think about the term antioxidant, but coenzyme Q10, the first compound on the market was the oxidized form of CoQ10, not the redox, not the reduced form. So again, the antioxidant tag that we put onto it is really incorrect.
Well, yes and no, because if you look at NRF2, one of its target genes is a gene called quinone reductase. Quinone reductase is a very potent phase 2 detoxification enzyme, but the other thing that quinone reductase does is it reduces quinones like coenzyme Q10, ubiquinone, and puts it back into the ubiquinol form. So regardless of whether you're taking oxidized or reduced CoQ10, your body, if it's capable of upregulating quinone reductase adequately, will just keep on recycling that.
You said the magic words, if your body's capable. So therefore, should we not be concentrating on these enzymes? You mentioned them before, glutathione and oxidized glutathione, and then you've got the enzymes glutathione peroxidase and...
Well, glutathione itself, it does have direct antioxidant capability, but it's largely a cofactor.
Yeah.
It's a cofactor for glutathione peroxidase, which is part of that primary superoxide reducing pathway. It's a cofactor for glutathione S-transferase, which is one of the phase 2 detox enzymes. So it's really part of the support cast. Unfortunately, I read all sorts of things online about glutathione is the master antioxidant. That means nothing in cellular biochemistry. The cell is this extraordinary orchestra, and it's just like saying the violins are the most important instrument in the symphony orchestra. You can't say that, and you can't say glutathione is the master antioxidant for exactly the same reason.
Yeah, that's right. Indeed, I think this is where the research falls down, because they try and use one or a very few antioxidants to mimic the complexity of the human body. And this is where I love foods as, it should always be the base prescription. We should be concentrating on this. This is why I love what you're doing.
Well, and that's exactly right. And I can't give you the quotation on this at the moment, but I do sometimes talk about a study where lycopene as the extracted molecule from tomatoes was used in a clinical trial compared with a whole tomato and tomato paste or puree.
Yeah.
The results for the food were very much more impressive than they were for the lycopene, and yet there was very much more lycopene being administered than the small amount that occurs in the food. So we tend to get these hero molecules that we hang on to, but in fact, they're not terribly effective when they're taken out of their normal contextual nutrient matrix.
Yeah, it's pretty hard to get the equivalent of a Mediterranean-style diet from a bland capsule. Christine, can I ask you, with regards to measurement of oxidative stress, is there premise for this? Is there a way to do it? Or do we wait till there's a discernible disease?
It's really difficult, Andrew, and I explored that for quite a number of years, and I came to the conclusion that most of the measurements that we tend to use are inadequate. For example, if we're talking about glutathione, there are tests which measure oxidized to reduce glutathione. They're not terribly useful, and one of the reasons for this is when a body is under stress, it tends to upregulate its defences initially. So there's some studies that have been done in Australia and looking at type 2 diabetic patients, and you would think when you have a type 2 diabetic, you would think their oxidized glutathione would be greater than their reduced. And in fact, it's the other way around.
Yeah.
And for quite a long time, this individual after diagnosis is mounting his own defence. And on average, it's about 16 years before you see the decline. So what that's telling us is we don't know. If you see a type 2 diabetic patient and he's got a glutathione level oxidized to reduced value, you don't know whether he's on the way up or whether he's on the way down.
It's a snapshot.
And it's completely useless. So I've come to the conclusion that the only measurement that I would even consider is the 8-hydroxydeoxyguanosine. So that's damage to the DNA. And I know it's kind of, closing the gate after the horse is bolted, because it's really the final step of the line. If you look at the tally of all of the oxidative injuries within a cell, they culminate ultimately in DNA damage. So to me, that is the only way I can get some overall impression of what's going on in an individual, rather than trying to highlight some little factor that's happening along the way that I've really got very little knowledge of.
Yeah, I remember reading a little bit about the isoprostanes, and I was thinking about, well, that's really only relevant for fat metabolism. It's a part of the arachidonic acid cascade, is that right?
Yes, it is.
Yeah.
It is. And it's widely used in the lab, and really we use it for tracking change, which is a little bit different from what you're doing in a clinical environment when you've got a new patient and you're trying to draw a conclusion. How much oxidative burden is this particular individual subjected to? Right. But if you're in a lab and you're measuring things, every so often, and you want to know whether something's tracking up or tracking down, it can be useful. But that's when you're in an isolated lab bench environment, which is, as you mentioned before, totally different from a free-living individual doing all of the myriad of things which we do on a day-to-day basis.
And when you're measuring DNA damage in the clinical environment, I would imagine that you'd have to run not one test, but a baseline and then a treatment level. Would that be right?
Definitely.
Right.
So, again, you've got to track what's happening. And that's where the enzyme quinone reductase is so critical, because it is the final enzyme in the phase 2 detox pathway that stops the DNA being mutated or prevents the formation of DNA adducts, which are mutagenic.
What's the relevance, in your opinion, of gene SNP measurement? I mean, we all have them. They don't change. You've got them at birth. We're sometimes lulled into thinking that that's the be-all and end-all, the diagnosis, rather than risk. What's your take on this?
Well, I see it like you do. I see it as a risk picture. So it gives me just a snapshot of, am I likely to see a good response in this patient in this area, or am I not? One of the things which concerns me greatly is the way in which the NTHFR gene has been seen by a lot of people now as if it's a diagnosis and virtually a death sentence.
Yeah.
The reality is we have been able to treat MTHFR SNPs for decades without ever knowing that they even existed, largely by giving a diet which is rich in plant foods, and in particular the B vitamins and, of course, B12. We've done that for years and never even knew it. But the real risk to me with such a SNP is in individuals thinking, I've just found out I've got this NTHFR SNP, and they use it now to attribute every condition they've ever had is now dependent on that SNP. Yeah. Then they go off online and buy ridiculous doses of a whole range of different supplements, which in many cases can make them worse. And one of the things that excessive 5-methylfolate does, and I mean really excessive, is to increase the oxidative burden of the cell. Now, no one's writing about this, but if you track the pathways through, you'll find that's exactly what happens. And those people who react badly have given themselves a great oxidative hit in the process.
Let's just wrap up that free radical snippet, if you like. Should we really be changing our vernacular to instead say signalling molecules?
Absolutely.
Right.
Yes. We used to think free radicals were the bad guys. They're actually important because they're the signal to tell, and they're a stressor, and they're the signal that says to the cell, if you keep this up, you're going to get into trouble. You better get into that DNA and switch on those defensive molecules now so we can stop anything happening. That's what they're there for. And the risk is you can mask those signals very easily if you take excessive levels of exogenous antioxidants. So that's the trap.
Right. So my thought process, and tell me if I'm wrong here, please, was that we need some of these stressors. It's almost like exercise is a stressor, but it's good unless you do too much.
Exercise. It's exactly like it.
Yeah, and similarly with mitochondria, let's say in a tumour cell, you need to stress that mitochondria to wake up the normal machinery to go, oh, heck, I've turned from being a normal cell into a nondescript cell and I need to apoptose. So you need that sort of, again, the signal.
You do. And so the way nature is operating, nature is constantly responding to these signals, and signals on a moment-to-moment basis.
Right.
And I think that's why, the thing about science is the more you know, the more you realise you don't know. And I have this enormous respect now for the signalling processes that are going on within the cell. And not just the signalling, the way Mother Nature switches on, switches off, foot on brake, foot on accelerator, continuously, all of the time. And I think sometimes we need to just give her the toolbox she needs and step back and let her do her thing and not try to meddle too much in pathways.
Right.
Now, I wouldn't have agreed with you 20 years ago because, we didn't know what we know now, but lots of things have changed in understanding the function of NRF2 for a start in controlling in many ways those cellular defences. You can switch on NRF2, you switch on a whole host of protective molecules all at the same time,
right,
which makes sense.
Okay, so, normally we would always favour a diet and we would always use that as a foundation. In some instances, like for instance, there's a very interesting trial going on at the moment with ice addicts. And they're giving NAC, N-acetylcysteine. Now, normally we would say a good foundation starts with the diet and you move from there. In sometimes this isn't possible. Now, the NICE trial is only just started. The results aren't out yet, but I wonder if we should stop thinking of NAC as quote unquote an antioxidant and use it for some other molecular process that it fulfills.
Look, I think so. If you keep in mind that NAC has been approved in paracetamol toxicity and as a mucolytic in cystic fibrosis and so on. Yeah. To me, that's a pharmaconutrient. We make our own NAC in the body, without a doubt, but we make it in very small amounts. So we are using this molecule as a pharmaconutrient. It'll be interesting to see what happens in the ICE addict trial that you're discussing. But, I mean, these are cases where the biochemistry of these individuals is already severely perturbed. And eating 3 square meals a day isn't going to change that, I wouldn't think. So you really have to intervene at a different level. Right.
But for most other things, I understand there's been some negative trials with NAC as well?
Yeah, they have. And really, in the lab, we use NAC in the lab all the time because it stops an NRF2 activation. So that weak pro-oxidant signal that you use to activate NRF2, you switch it off by giving a dose of NAC. So it's a potent antioxidant in that right, but it's blocking signalling, and that's what I don't like about its broad use.
Right.
And also the fact that being mucolytic in the respiratory system may also mean that it's mucolytic in the gut. And I don't think there's been enough research done on that yet for us to really know whether that's perturbing other things.
How very interesting. And then we get to the microbiome.
Exactly. And, you know, the innate cell defence of having a nice mucin layer lining the entire, gut lumen.
Oh, that's interesting.
That's why I call it a pharmaconutrient, because it's like a pharmaceutical, that there are the good effects and the not so good effects.
Right.
And I think we need to explore them.
Absolutely. Okay, so let's move on to the nutrigenomics compounds that you use, and you favour sulforaphane. And again, companies will try and put their mark on it. Ours is best, theirs is best. That's just marketing. But what's the science of sulforaphane? Where did it start?
It started in 1992. There was a group at Johns Hopkins University that was led by Professor Paul Talalay there. And they were using it, really looking at cancer protective molecules that can prevent the cancer process. So that's where they started. And they found that the sulforaphane is very much more concentrated in the broccoli sprout than it is in the broccoli vegetable. Everyone's known for years that cruciferous vegetables are beneficial for health and they're protective against cancer. But the Talalay group were attempting to find out what that was. So the reason that the sulforaphane yield is much greater in the sprout is that the precursor compound, glucoraphanin, is in the seed, and you don't produce any more of that as the plant grows. So therefore, you're basically just diluting it. And by the time you get from this tiny little brown seed up to a full-headed broccoli, you've really diluted that activity. But there's actually no sulforaphane in any cruciferous vegetable. There's a precursor glucoraphanin and there's an enzyme myrosinase, and they're separately compartmentalised within the plant cell. When you chop or break or chew that, the myrosinase enzyme attacks the glucoraphanin, and that's what produces the sulforaphane. So in the production of such supplements, you have to be very careful that you're retaining both the glucoraphanin and the myrosinase enzyme. And a lot of the US supplements in particular just retain the glucoraphanin as an extract, and they don't retain the myrosinase.
Yep.
They yield very little sulforaphane because they're then reliant on what's going on with certain species of the gut microbiota which have some myrosinase-like activity, but it's only about 10% of what you would have if it was retained in the plant. So the real advantage of sulforaphane is not only is it the most potent inducer of NRF2 or activator, but it's also highly bioavailable. It's a very tiny, low molecular weight lipophilic molecule that just glides straight in through the cell membranes, and it's about 80% bioavailable, whereas the big bulky polyphenols are about 1% bioavailable, just simply because of their chemical structure.
Yeah. This is a very similar story to garlic.
Yes, because garlic relies on the enzyme, exactly the same concept.
I would imagine that there's a whole host of foods that we have to be careful of when we're certainly supplementing, but also looking at packaging them, that we have to be mindful of their freshness.
Mm-hmm. Exactly.
So, Christine, you mentioned the polyphenols were poorly bioavailable, but that doesn't mean they haven't got health effects. Tell us what's happening here.
So the polyphenols, they are big, bulky structures. So we used to think that they were getting absorbed into the cells and they were having an antioxidant effect within the cells. More recent research has shown that they don't get absorbed more than about 1%. But clearly they have therapeutic effects. So what's happening? First of all, they reduce the oxidative burden within the cell. So I mentioned the blackened barbecued steak earlier. So they will quench those radical species in the gut, so you get that direct effect. Secondly, they are now considered to be a prebiotic food for the microflora in the gut, and they tend to focus on producing additional amounts of some of the lesser-known species like Akkermansia, Mucinifera and so on. So they have a direct prebiotic effect, and in the process, the microbiota break these big, bulky molecules down into smaller metabolites, which clearly are being absorbed. And we're thinking now that some of the beneficial effects that come from these polyphenols are not from the original molecule itself, it's from the variety of metabolites that are being produced in the gut. The problem with this is we each have a unique microbial signature in the gut, and so the metabolites that you produce won't be the same ones that I produce. And so this really makes the clinical studies very difficult now because you don't have the level playing field.
No, that's right.
It's a whole pretty exciting area of research now that's very, very active, and I think in time we'll probably get some more answers to this. But interesting, yes.
I remember a few years ago that, they thought they had I think it was the basic 3, do I say the word phenotypes, of healthy gut microbiotas or microbiomes. And then I think it was not 6 months later, they went, no, we got it wrong. There's no way. We have this shotgun effect. Do you think we'll ever get to the stage where we'll have not one healthy prebiotic, but a mix of prebiotic foods that we know can favour healthy gut microbiota? You've mentioned Akkermansia mucinifera. There's, Faecalibacterium prausnitzii. There's the Veillonella species. We go on and on. But do you think we'll get to that stage where we'll say this is the sorts of foods that we need to incorporate to help our gut?
Well, in fact, we teach that in the GEM protocol already. So we have a whole list of prebiotic-containing foods to the best of our knowledge at this time, and we talk about diets of inclusion, not diets of exclusion. I'm only interested in excluding foods for which there is a known adverse reaction for that patient. Right. Otherwise, I want to improve the diversity and variety of foods in the diet as quickly as possible. So in the short term, you may use your particular prebiotic supplement, and I recommend that anyway. But as time goes by, you need to be phasing that out and having this whole array of different types of foods. Things like the galacto-oligosaccharides, they're in legumes. And, the inulin family, it's in onions and leeks and so on. So we can go through a whole host of different prebiotic substances which are available in supplement form and find the foods that they come from. So I like to encourage those foods to be introduced into the diet as soon as the patient's intolerances have been removed. And part of what we do is to try to restore the gut epithelial homeostasis and its underlying immune network so that we can build out those food intolerances.
Gotcha.
I think it's really unfortunate that we've got now people online in particular promoting the avoidance of vegetables because we shouldn't be getting lectins. I mean, you practically cut out all of the plant foods in the diet by doing this. So we've got histamine intolerance, lectin intolerance, salicylate intolerance. It's just getting ridiculous. And I've spoken to people who were down to 5 and 6 foods only that they can tolerate in a day, and they are very hard to reverse because the nutrients they need to recover are in the foods that they're not eating.
Yes. Mike Ash calls them the mashed potato and peas brigade. They just go down this ever-increasing spiral of excluding food after food until they're on this extremely basic diet, nutritionally deficit, and they're extremely wasted and emaciated. They have no resilience and everything. That must be a real trick to reinvigorate that. And there's a real clinical responsibility there to do it properly. So how do you get these patients back?
Well, one of the things we focus on is the intestinal epithelial cell as a key player.
Right.
Because if you enhance the function of that cell, and NRF2 is part of that story, once you get those cells working as they should, they are modulating this whole underlying immune network. So we're upregulating infection control, we're down-regulating inflammation, we're down-regulating the allergenic response, and we're down-regulating autoimmunity. The gut immune interface is entirely capable of modulating all that if you get those cells functioning as they should do.
Right. And of course, that's got to involve measurement. So what sort of things do you look at to measure? Like interleukin-1b, IL-6, TNF-alpha? What do you measure there?
Well, those are the key inflammatory cytokines, but in the short term, I'm not particularly interested in measuring anything.
Right.
And that might sound a little peculiar, but the patients who come on this journey really have been tested and measured to death. They've done everything. They've tried every diet. They've done every test. I'm just interested in restoring homeostasis, and the symptomatology will tell you that pretty quickly, and you will see how recovery is occurring. And what I find then is because of the cardiometabolic connections to what's going on in the gut and chronic disease in general, if your patient comes to you with half a dozen symptoms that are really bothering them, after you restore gut immune homeostasis, they might have cleared 4 of those symptoms and there are 2 left.
Yeah.
To me, that's now time to get in and start finding out whatever didn't clear up, why didn't it clear up, where is the problem, how do we test it, what have we got available to us. So I don't do a whole lot of tests at the outset because I think we can restore that function without testing anything. We've got all sorts of issues with how reliable is zonulin antibody testing.
Yes.
And I mean, a lot of these tests are not quite what you'd like. Lipopolysaccharides would be a useful monitor. But to be honest, I find a lot of people have burnt a lot of dollars in trying to sort these things out along the way. And if you can encourage them to go on 6 or 8 weeks or something of a program without having to spend any more money on tests, they pretty much buy into that.
What about the integrative laboratory testing of detox capability of drugs? Like, for instance, they use aspirin, paracetamol and caffeine. Does this give you any idea about the patient's capability to handle, insults, if you like?
Look, it would give you some indication of the capability at the point you tested it, but I think then you're probably better to go back to the nutrigenetic profile and have a look at genetically what they'd started with. I think that's a better way of seeing what the capacity for recovery is going to be.
Okay, so let's talk about this nutrigenetic report. What's involved with this?
Well, the patient takes the DNA swab that gets sent off to the lab, and depending on the particular company that's providing the report, they'll then categorise a number of genes in different ways. So we're not testing the whole the whole genome. We wouldn't know what to do with it if we had information on 25,000 genes. It's a bit fanciful. But, in the vicinity of 50, 75, 100, most of those genes have been validated to the extent that we know that we can attach some meaning to the report when it comes out. But I particularly like the reports that categorise the genes into functional groups. So I'm particularly interested in looking at core upstream factors that govern cellular defences. So I want to look at genes that govern redox balance, inflammation, detoxification processes, cellular energetics, and methylation. And they're my core groups that I like to look at, and that will tell me that individual's capacity to a large extent to respond to an intervention.
Okay, so what happens next though? What do you teach clinicians to master when they're incorporating the GEM protocol?
So if we call the intestinal epithelial cell mission control of the gut ecosystem. So I want to focus on that cell in the short term.
Okay.
So if I look at those cellular processes, so we know the intestinal epithelial cell, just like any other cell in the body, will respond to NRF2 activation. It will respond to NF-kappa B downregulation. So that's going to enhance redox control. It's going to reduce unregulated inflammation. It's going to enhance detoxification processes. It'll increase glutathione synthesis. So all of those core factors that any cell needs to work normally will be enhanced by activating NRF2. And I use a high-yielding sulforaphane supplement of about 20 milligrams a day to do that. So that's the beginning. The immune interface, or the gut immune interface, which lies just below the intestinal epithelial cell, we largely target by enhancing the toll-like receptor 2 activity. So on those epithelial cells, a whole lot of toll-like receptors. The toll-like receptor 4 is the one that picks up the endotoxin, so we don't want to focus on that. And we use a diet low in saturated fat, particularly low saturated animal fat, to downregulate toll-like receptor 4. But we use a prebiotic, which is actually called an immunobiotic, which is a dead Lactobacillus plantarum cell, which has been optimised for its cell wall content of lipoteichoic acid. So lipoteichoic acid, or LTA, attaches to toll-like receptor 2, and that sets off a whole host of immune modulating processes which tend to enhance infection control and downregulate inflammation and downregulate allergenicity. The other thing that activation of toll-like receptor 2 does is that it improves the tight junctions. And we spend a lot of time in the training talking about the gut barrier integrity and the importance of the tight junction control. And it's a big story that has got much more than gluten that's associated with it. And I think it's unfortunate there's this focus on gluten as the fall guy here, when in fact one of the most significant factors that downregulates those tight junctions is a high HbA1c level. So in any pre-diabetic or diabetic patient, you can expect there's going to be problems at the gut barrier and vice versa. And we spend a lot of time talking about this feed-forward loop where a perturbed gut barrier is feeding cardiometabolic disease, and then the cardiometabolic disease, which is likely to have an elevated HbA1c, goes back now and perturbs those tight junctions. So you can't treat one without treating the other.
Right. You're getting onto an area that I was just going to ask you about, and that is, do you think we're at the stage now, and I think you've just answered this, but with regards to specific groups of polyphenols and specific bacteria or bacterial cell walls being used as a therapy to help each other, to bring about rejuvenation of the gut lining?
Yes, and I think what this new area of immunobiotics has done is it's taught us some of the properties of probiotics. I mean, I think for a long time, most of us, I certainly did, thought that a lot of the benefit of giving a probiotic supplement was the competitive exclusion. Basically, you'd push the bad guys out of the way. But there's a completely different story now associated with what probiotic supplements can do. And this whole idea of the LTA marker or bioactive biomolecule that's on the wall of the gram-positive bacteria just puts this in a totally new light. And even to look at the way that when you activate toll-like receptor 2, you really upregulate infection control within the cell. So it puts a totally different slant now on how we deal with infectious disease.
Yeah.
And I wasn't aware of that until the last couple of years.
Okay, so does this answer the question about basically having a healthy fence? That, we like probiotics because we think they've got a smile on their face. But indeed, that's not the case. They talk to our body, they talk to our immune cells and say, listen, I'll stay outside here, won't cause you harm. And the body says, well, I'll help you as long as you stay on that side of the fence. So I'll make this nice gushy layer of mucin, 2 layers in the colon. And you can embed there, you can have a home, I'll help you, you help me, but you stay on that side of the fence. So is this really just an immune reaction, albeit a less confronting one?
Well, that's right, but just about a year ago, September last year, there was a paper published which shows that it's actually the function of the colonocyte that is driving the population of the microbiota. And
say that again?
It's the colonocyte that's determining who lives and who doesn't live in terms of the microbiota within the gut. The control is coming from the colonocyte. And I thought that was brilliant when I saw that, because that is exactly reaffirming what I've been working with the GEM protocol over the last couple of years. So yes, it's a symbiotic relationship without a doubt. But I think the other thing that really led me to develop the GEM protocol was a few unanswered questions. And one of them was that when you look at the microbiome, or you look at a microbiome analysis, and you see all these ups and downs of maybe 50 different species, and I've got a probiotic supplement in front of me that's got half a dozen different organisms, how do I know that they're the ones that my gut wants? And, of course, the answer to that is I don't. And the other issue is that probiotics don't typically colonise in an adult. So there's the other issue. I think we thought you would put them back after, assault from antibiotics, but you don't actually put them back. And that's where we come back to this idea of restoring the gut ecosystem and using prebiotic foods to feed whichever organisms need to be fed, and let Mother Nature do the fine-tuning on that. I don't think we have the ability to manipulate the species in the microbiome as we think we might.
Right. But at least maybe not for long-term health. I mean, there's certain evidence to show benefit of, antibiotic-associated diarrhea and things like that using Lactobacillus GG.
Most definitely, yes. But that's symptomatic, and some of the best research on probiotics is for enormous benefit in conditions, and inflammatory skin conditions and respiratory conditions, and a whole host of different conditions. There is no doubt that they're extremely beneficial in that regard, but it doesn't fix things in the long term. No. It's not a long-term solution. So that's the difference. And that was, again, a question that I asked myself. What am I trying to achieve here?
I've always had this question about probiotics, particularly when they say they're isolated from a human. And I thought, what did that human die from? Are you perhaps increasing a risk later on? We just don't know this long-term stuff.
And the other thing that amuses me too is we put up the Hadza tribe in Tanzania as some sort of a benchmark for the perfect microbiome. But if you do a little bit of research on the Hadza tribe, I don't think you or I or anyone listening to this program wants to eat exactly what they eat, because fur aside, it is the whole animal.
And it is such. You've obviously read the blog of Jeff Leach, where they fricassee the colon. They push out the plant food of the antelope, and they fricassee the colon and pass it round. Hardly what we'd describe as sashimi.
So if I've got a few extinct species, I think they can stay like that. That's what I have to do to get them back.
So where's the future? What's your research? Where's it leading?
My research in many ways has done the full circle in however many years it is since 1975 when I started practice, because I started out with food, and I'm really coming right around the full circle again to look at foods and food molecules that have been validated scientifically. And I said this earlier, I think we need to give Mother Nature her toolbox and then stand back and let her do what she needs to do. And I say that because of the intricacies of these modulatory mechanisms which occur within cells. I mean, we look at a metabolic pathway and we can draw it out on a piece of paper and we think that's lovely and we try to manipulate that in some way. But what we don't take into account is that on a moment-to-moment basis, there are modulators in there. There's little foot tipping on the brake continuously in the cell in response to signals up, signals down. We can't possibly ever replicate that.
Right. I'm going to go right back to enzymes again. And I know this isn't the biochemical enzymes that we've discussed, but digestive enzymes. What do you think the relevance is for supplying somebody who is stressed, not eating well, sympathetic nervous activation? What do you think the relevance is about supplying them a good, healthy diet, some nutraceutical, phytochemically active biofoods, plus maybe some digestive enzymes to help them absorb those substrates so that they can be used? Is that worthy, or should we just concentrate on eating?
No, I think you're right, because when there is chronic inflammation at the gut wall, that inflammation will impact the intestinal villi, and you'll also impact the ability of those intestinal cells to produce enzymes, and pancreatic as well.
Right.
And therefore, yes, in the short term, there is often merit in using a digestive enzyme, hopefully not for the long term. As you get control of that gut ecosystem and that inflammatory state that's in there, you ought to see recovery of those enzymes. So I never see them as a long-term solution.
Right. So you teach people how to eat well, chewing like Grandma did?
Something like that.
With regards to the GEM protocol, when you're talking about a patient who has lost their resilience and you've now rejuvenated them back to when their symptoms are under control, let's talk about this healthy eating. Like, do you get people off the phytochemical supplements and get them to then concentrate on, choosing their foods? And where does this fit with people who have traditionally avoided vegetables, which, I mean, you and I would love? I sit down to a plate of Brussels sprouts and I just go, yum. That's not what most blokes would do.
And many women too.
Right.
Look, it's difficult. In an ideal world, yes, and we'd be looking at 600 to 800 grams of non-starchy plant foods a day. There's a couple of good studies that show why that amount. But in a real world, that isn't always going to happen. We know that. And so for that reason, I guess we just do the best we can to persuade the patient that the more food you eat, the better they're going to be. Unfortunately, I've been in a situation in clinic where they listen to your beautiful little presentation, they go, just give me the pills.
I can see that happening, unfortunately.
Yeah, so anyway, look, it's on a patient-to-patient basis, so I'm not naive enough to think that we can get everybody doing that, but it doesn't stop me telling them the value of doing that. And I hate to think that I'm going to prejudge a patient's ability to take up whatever information I give them. I like to be told the total story, and then I can decide what I pick and choose from that. And I think a lot of other people do that too.
Yeah.
I remember some years ago looking at diabetic education, and they let you have an Arnott's biscuit, and they let you have this and that, because patients won't stick to it. I mean, how patronising is that, really?
Yeah. We've been favouring, what is ostensibly the Mediterranean diet, a plant-based diet, and that's what we've been discussing. How do you use the GEM protocol, or indeed phytochemicals, when people are, on, say, the ketogenic diet?
You're asking all the controversial questions, aren't you? I think one of the biggest issues for the ketogenic diet is defining it. So my understanding of the ketogenic diet as it originated back with Atkins was that you had a keto stick and you measured the degree of purple on the stick to give you an indication of what sort of level of ketones you were producing. As I understand it now, people don't do that test, and what they're calling a ketogenic diet, I don't think would have them remaining in ketosis. I think it's a low-carbohydrate diet, which is not necessarily ketogenic. And the more I speak to people about this, the more convinced I am that most people are not really in ketosis. So that's another story, and I'm very much in favour of avoiding excessive carbohydrates if you're not doing enough exercise to burn them, and certainly we get rid of all processed, refined carbohydrates. And I think if we're having a low carbohydrate, strictly ketogenic diet, we are starving the microbiome, and I think there's plenty of evidence to show that. Because what the bugs will do is if you don't feed them the right fibres, they chew into the mucin layer, because those mucopolysaccharides at the gut are beautiful prebiotic foods for the little microbiota that live there, and they'll chomp into them, which I think in many cases is the beginning of the loss of innate immunity. You're eroding away that mucin layer and promoting inflammation, and downhill we go very quickly.
I think you and I are both favouring the Mediterranean-style diet. Certainly I am, because not only is it not just the food, it tastes good, not just that, but the social interaction, and also it allows alcohol. But
Well, I did want to say something. Interesting, Andrew, that you talk about the Mediterranean diet. I'm very much in favour of that style of eating as well, although I never use that label. However, when you look at foods that do similar things to gluten, to the tight junctions, you find that gluten tends to open the tight junctions within the gut barrier. So does alcohol, and so does hops.
yes.
However, the polyphenols that are in red wine actually tend to close the tight junctions. So perhaps the alcohol that is opening them and the polyphenols that are closing them have this cancelling out effect, and so everything's fine.
I wonder if we'll get to a stage with regards to zonulin occludins and the zonulin complex that, you know, it's not just an open or shut situation, that it cycles open and closed depending on what the body needs to accomplish.
It's a dynamic structure that is continuously opening and closing. I hear people say you've got to seal up that leaky gut, and I cringe when I hear that. I never use the term leaky gut, because it isn't that. It's a dynamic structure that becomes unresponsive.
Christine, that's a subject for another day, I think. Thank you so much for taking us through your scientific work, but also the production of the GEM protocol and how you can help clinicians to help their patients with regards to their, not just their gut problems, but their whole immune issues using phytoactive phytochemicals. So thank you so much for taking us through just a snippet of it today.
It's been an absolute pleasure, Andrew. Thank you.
This is FxMedicine. I'm Andrew Whitfield-Cook. If you're loving our FxMedicine podcasts, please don't forget to share us with your colleagues, family and friends.